The next case we're going to look at is value at risk. In financial terminology, value at risk is the estimated potential loss that one may suffer over a time fence. So you specify a time fence, you say what is the value at risk for 1 day or value at risk for 5 days. Um, so we're going to calculate value at risk over 5 days in our example. And what the criterion is to look at, so you invest a certain amount of money, and then you say after a time period, say 5 days, okay, what is the, don't look at what the best is, but what could be the worst, okay? What is the least amount that this would be? Like 1,000, if it is a really good stock, then 1,000 could become, let's say, 1,500 in 5 days on average, but at the very least, it'll be like 1,100, right? So you, at the very minimum, make $100 in 5 days. But let us say that you invest 1,000, and the first percentile, so that is, there is only 1% of the time the value is going to be less than this. That's your first percentile. If the first percentile is say 9,500, then I'm sorry, from $1,000 it is $950. Then at the first percentile, that in other words 99% case on the left side, okay, so you lose $50. So at 99%, your value at risk for 5 days is $50. So that's the kind of idea. So here, the hypothetical investment of 1,000 in a single stock, and we have daily stock price data in the Excel file for 3 years. And we're going to compute a 5-day continuous rate of return. So that's your log return that we talked about. So usually rate of return is the ending price minus beginning price divided the beginning price times 100, right? Now for continuous compounding, also known as log return, we'll use ln of ending price divided by the beginning price. And then we will estimate, first we will set up a deterministic model, and then we will simulate. So we're going to look at the 5th percentile and the 1st percentile of the log returns. And with that we will calculate the value at risk. So that's your 1st percentile is what we are interested in, and we're going to throw in the 5th percentile as well. So instead of deterministic, we'll fit a model for the 5-day return probability distribution, okay, like what we did previously, and then simulate our 5-day return and compute the 5th percentile, the 1st percentile, or 99% risk. All right, so that's what we're going to do. So we're going to look at the distribution fitting one more time. And we're also going to look at bootstrapping that we talked about earlier. So, and we'll look at parameter uncertainty and model uncertainty as well in this context. So let's head on over to Excel and set up the deterministic model. So here we have date and the adjusted close. So if you want to look at daily change, then you will do ln that divided by that. So that will be your continuous compounding daily, right? Now if you do 5-day, okay, so here, so that'll be ln that divided by that will give you a log return for 5 days. And we're going to look at 5-day return. We're just doing a copy that. Okay, so we're doing daily change just to throw in daily change. All right, so we have now 5-day return Okay, so the deterministic model is here. So we have an initial investment of $1,000, right? Now, these are the 5-day compound returns. So fifth percentile will be percentile EXC. That's the one that we need to use. Okay, so go here. So we look at all the 5-day returns, right? And then specify 0.05 for 5-day return. Okay. So that's your fifth percentile. So fifth percentile, 95%, you have a loss of about 5%. So let's go into edit mode, copy that, and paste it here and change the 0.05 to 0.01. So that will be the first percentile. Let's change this to percentages. Okay. So value after 5 days will be, so you have the initial investment times 1 plus the return. Now let's make G3 absolute reference so we can copy that. All right. So the value at risk is $1,000, the initial investment, make that absolute reference, minus what that $1,000 will be in 5 days at the first percentile. Okay, so there's a 1% chance that this will be the case. So this, we are looking at the potential exposure to risk. So you do it at, this one is 5%. Okay, and copy that down. So that will be at the first percentile. So this is 5%. This is 1% risk, value at risk. Okay. So now this is a deterministic model. So now we're going to fit a probability distribution for this 5-day change, and then we will simulate the value at risk.